In this short video, we will introduce the concept of field points and how they are used to compare molecules. Cresset's philosophy is all about looking at ligands the way they are seen or experienced by the protein receptor. To do this, we step away from the two-dimensional representation and consider a ligand as something that has a three-dimensional distribution of shape, charge, and hydrophobicity. Now, comparing molecules using the full molecular electrostatic potential energy surfaces is computationally expensive, so we've condensed this information down to what we call field points, which are placed at areas of local extrema in these potential energy functions. Blue corresponds to areas where the electrostatics are negative, red corresponds to areas where the electrostatics are positive, yellow gives a van der Waals surface area, and orange points are in areas of hydrophobicity. The size of the field point corresponds to the strength of the field at that point in space. The presence of a field point suggests that this is an area of the ligand which may form a favorable interaction with a protein receptor. It is noteworthy to say that just because a field point does not appear, it doesn't mean that there is no field at that point in space. It's simply that the field is not at a maximum value at that point. With Cresset software, we use these 3D field point patterns to compare molecules in a biologically relevant way, the way that a receptor would experience the ligand. For example, if we have the bound conformation of cyclic AMP with this field point pattern, and we have a synthetic analog that has a similar field point pattern, then the receptor should see both of these molecules in the same way, regardless of how similar or dissimilar their chemical structures are. This allows us to compare molecules at the bioisosteric level without bias. Going a step further, the technology can be used in the ligand design process for optimization or scaffold hopping, which is shown with the changes made to the center molecule to give the molecule on the right. We do these comparisons with 4 products. Blaze is for virtual screening, Spark is for bioisosteer replacement and scaffold hopping, and Torch and Forge are for design and understanding structure-activity relationships. To learn more about our software and technology, please visit our webpage, www.cresset-group.com/products, or contact us by email at inquiries@cresset-group.com.